Okay, here we are for the third instalment of the functions and relations revision. The first question we have here, state the maximal domain of the function f of x is equal to the square root of 5x take away 7. Now with this particular one, what we should do is take the component which is inside the square root, 5x take 7. I'm going to set that equal to 0 to work out where the limit of this particular function is going to be. There's obviously the bit inside there can't be a negative because we can't take a square root of a negative, so we need to find the limit. So 5x take 7 equals 0. We'll add 7 to both sides, which gives us 5x is equal to 7. Then we'll divide both sides by 5, which will give us x is equal to 7 over 5. So that's going to be the limit for our particular graph, and the graph will look something like this, x and y, so it'll go something like that with our limit of 7 over 5. So the maximal domain is going to be anywhere from 7 over 5 upwards. So what we'll do with this one is we'll say that our maximal domain is 7 over 5, and infinity. Always have a round bracket with infinity. When we ask the question, can this function equal 7 over 5? The answer is yes, so we'll give it a square bracket there. That's the answer. Let's move on to the next question. What is the range of the function where the domain is negative 7 to 0 mapping onto R, where f of x is equal to 7 take away 2 by the square root of 9 take away x. Now to give you an idea of what the graph of this will look like, we'll go through a couple of little steps. Firstly, if we consider the graph of just the square root of 9 take away x, the graph of that will look something like this. So this will actually start at 9 and it'll have an x-intercept of 3. Oh sorry, a y-intercept of 3. What am I talking about? Because when x is equal to 0, 9 take away 0 is 9, so square root of 9 is 3. To make y equal to 0, 9 take away 9 inside the square root would equal 0. Now if we take it the next step and we have a look at the graph of 2 root 9 minus x, that's going to be double the previous graph, so it's going to have the same shape but double the height. So it'll still start at 9, but it'll have a y-intercept of 6 instead of 3. There should be a little y up there and an x over here. And then we go a step further. I'm just changing the colour here to have a look at the graph of 7 take away 2 root 9 minus x. So that's going to be 7 take away that blue graph that's there. 7 take away everything there. So the graph will look something like, we'll have a point that it approaches at y is equal to 7. So this value here, where we had the previous x-intercept, the y value of that is 0. So 7 take away 0 is going to be 7. So we'll have a point up here at 7 where it starts. And then when we look at our previous y-intercept of 6, the y-intercept of our new function is going to be 7 take away 6, which is 1. And the shape of the graph will be upside down, and it'll go something like this. Okay, so starting at 7, crossing over y at 1, and going further into the negative realm eventually. So with the question that we have in hand is our domain is restricted from negative 7 through to 0. So we're basically looking at this realm here somewhere of -7 going through to the y-axis. So, and it's not a linear, but it's certainly a one-to-one function going through there with a continual, it's a positive gradient going through there. So what we can do is we can just basically look at either end, the limits of either end of this. So when x is equal to -7, we'll find out what the y is equal to. So the function of -7 will be equal to 7 take away 2 root 9 take away -7, which equals 7 take away 2. 9 take away root 7, take away -7 is 16, so we're looking at the square root of 16. 7 take away, square root of 16 is 4, 2 times 4 is 8, so that'll equal -1. And then if we look at x is equal to 0, then the function of 0 will be 7 take away 2 root 9 minus 0, which is 7 take away, square root of 9 take away 0 is 9, square root of 9 is 3, 2 times 3 is 6, 7 take away 6 is +1. So that tells us for this question that when x is equal to 0, which we knew that already, that y is equal to 1, and it also tells us when x is equal to -7, then our y value there will be -1. So that tells us the range will be from -1 to +1. And we need to work out if we have round brackets or square brackets. So if we have our -7, we look up here at the original question, the -7 refers to a negative bracket, so on our graph we would have an open circle there, so a round bracket corresponding, and we have a square bracket corresponding to the 0, so we're going to have a square bracket corresponding to 1 for our range. And that's the answer to that question. And we'll move on to the next one. Yeah, if we look at this one, we've got the real numbers map onto the real numbers, so there's no restriction in the range or the domain except for what it's allowed to equal, I suppose. So we have an interesting little set of brackets here, so I'm going to have to expand that out, just sort of simplify the function a little bit. So f of x is equal to, get rid of these square brackets, so that'll give us negative x minus 2 squared, and then we have to apply the negative to the 9 as well, so take away 9. So that's what our function is. So that tells us that it's going to be an inverted x squared graph, which is translated to the right by 2 and down by 9. So the graph of this will look a bit like something a bit like this, where we have a turning point at 2 and -9. So the range for this particular function will be anything from 9 downwards, so going as far as -infinity. So for the range, that'll be from -infinity through to -9. Can it equal -infinity? We always put a round bracket with infinity. Can it equal -9? Yes, that's where the turning point is, so we will give it a square bracket there. So it's -infinity through to -9. Well, it looks like a bit like a G there, so I'm just going to take the tail off that 9. Yeah, it looks like an A. Can't win, can you? -infinity through to -9. Okay, let's go on to the next question. If f of x is equal to 3 by x take 2 squared minus 11, then f of negative 3 is equal to, basically what we're doing is we have to substitute x with negative 3. So f of negative 3 will equal 3 by negative 3 take 2 squared minus 11, which equals 3 by neg 3 take 2 is neg 5 squared take 11. Now we'll do the square first, BODMAS, or do the order. So negative 5 squared is 25, positive 25, so it's going to be 3 times positive 25. Take 11, 3 25s is 75, and our answer to that will be 64. And that's the last of the questions for this particular screencast.